All right, the next function is the inverse of cosine. Again, cosine is not one-to-one function, but again, we can restrict the domain so that we can define inverse. So as you see here, if you restrict the domain to interval from 0 to pi, we have a curve like this. Whenever you draw a horizontal line, it intersects the line at most once. So this is one-to-one function. So we restrict the domain to from 0 to pi. Good. Again, let me draw a quick diagram to illustrate what inverse of cosine does. So cosine assigns some value to each angle. So we are restricting our domain to interval from 0 to pi, and the value is from -1 to 1. So you are assigning certain value to any angle in this interval. When you define inverse of cosine, it assigns some certain angle to value. So here is a quick example. When you have 1/2 inside the inverse of cosine, well, here 1/2 is some certain value here. You are after some certain angle so that cosine of x is exactly 1/2. So again, you can start with letting this given expression x. So then by definition of the inverse function, we can say the original function assigns 1/2 to this angle. And you are after this angle x so that the value is 1/2. So look at this graph. 1/2 is somewhere here. So you are after angle. And then this angle is pi over 3. So x is pi over 3. That's it. Well, there are more examples, but I'd like to focus on some kind of standard examples. All right. Okay, the last function is inverse of tangent. So tangent repeats this pattern for every pi. So it's not one-to-one function, but we restrict the domain to certain intervals so that it is one-to-one. So for this tangent, we need to take open interval. So from, tangent has vertical asymptote at -pi/2 to pi/2. So we restrict the domain to open interval from -pi/2 to pi/2. So we are not including two extreme points, two end points. We are taking only open interval. Again, what tangent does is to assign some value to angle. So domain of this tangent is now from -pi/2 to pi/2, and value can be any real number. Remember, this fancy R stands for the set of all real numbers. And for this example, arctangent of -√3. By the way, arctangent is same to inverse of tangent. So this is inverse of tangent, -√3. Yep. Similarly, arcsine is inverse of sine, arccosine is inverse of sine, and so on. So here we have inverse of tangent. It assigns some angle to value. Now we have value -√3, and we are after certain angle so that tangent of x is exactly square root 3. So again, if you let arctangent of negative square root 3 is x, then we can say tangent of x must be negative square root 3. So negative square root 3, where is the negative square root 3? So here is the negative square root 3. So you're after this angle, and this angle is negative pi over 3. So that's it. So our angle is negative pi over 3. Okay, so let me emphasize the graph of sine, cosine, tangent. Well, understanding graph of sine, cosine, tangent is very important. First, once you have graph, you visualize the function, you understand the function better. Because simply to see is to know. So understanding graph of sine, cosine, tangent is very important.